So first what we will do, we'll start with the in the pre-order traversal, we will start with the root node. Here our root node is A. Okay. Now what we will do, we will visit A following these three rules. First, visit the root, traverse the left subtree, traverse the right subtree. Okay. Now to traverse it, we can use a very simple rules that every node we take, we'll break them down into left child and right child. So first visit A, as this is the root. What is the left child of A? That is B. And what is the right child of A? That is C. So we're done. Okay, let's go for the next line. Now we are done with A. Now let's go for B. Which one is the left child of B? D. And which one is the right child of B? Is E. So we're done with B as well. Then go for the C. So again, the root node, the left child and the right child. So we are done. Again, let's go. A, B is already done. Okay, D have a left child, that is H, and the right child, that is I. E is already done. You don't have any child. F is already done. G is already done. Now, let me clarify one more time what I did. I first started with the root node, that is our A. Okay, so this is our root node, that is A. So whenever I wrote the root node, I actually tried to expand, or I tried to write the left child and the right child of the root node. So the left child of A was B and C. So basically what I have done, I have expanded. Okay, I have written all the left child, right child of the A. So we're done with this line. Is there any, let's go for the next line. What I did, I expanded B and C. Okay, so what was the left child of B? That is D, and the right child was E. So it became D and E. And then again, I expanded C. The left child was C was F and G. Now, do I have to do it like this? No, you can do it in one line if you want. Okay, I have just shown you step by step so that you can actually get a better understanding of this one. That's it. Okay, but you can actually break it down step by step. So what are the rules? Take the root node, write the left child, write the right child. Left child, right child, done. Again, take the root node, that is B. Here you see B. Write the left child, write the right child. So D and E. So there is another name for it. Instead of, we can say that visit the left child and visit the right child, or we can say that traverse the left child or traverse the right child. The bookish term here is, we call it traverse the left subtree, traverse the right subtree. So basically what I want to say is that it's totally up to you that what you call it, but the operation is actually very simple. Okay, now let me give you an exercise to do. So let's just change this one a little bit. Okay, let's make it K. I don't think there's any other K here. And let's add another one, L. I know this is a binary tree. There cannot be more than, okay, let's keep it a binary tree. Okay, now you have 2 minutes. Okay, try to solve, try to write the pre-order traversal for this given tree. Your 2 minutes starts from now. So root is A. Okay, the left child is B and the right child is C. Then what is the left and right child of B? So we start with B. The left child of B is D and the right child is E. What is the left and right child of C? F, G. Then we again go for the next one, D. So what is the left child of D? That is H and I. So basically, you see, we are actually pushing it every time we have new values. We are basically changing the changing it to some right shift. Then we have E, and what is the left child of E? That is K. And finally, in the other case, for the G, we have M. Now, the thing is, it doesn't matter how you do it. Okay, you can do it in one line. You can do it in step by step. It's totally up to you. But if your calculations are correct, you will have an answer like this one. Now, is there anyone who have a different answer? In the pre-order, we'll start with the structure. The structure is called node, and we have seen in a node there will be now data and the left and the right pointer. Previously in the linked list, we used a pointer, called the next pointer, the previous pointer. and in this case we are using a left pointer or right pointer. Okay, then in the pre-order case, okay, what we start with the node root. If the root is null, we return, because the root null means there is actually no tree. But if the root is not null, we call pre-order function, okay, with root left, or we call pre-order function with root right. Now you see this one is actually a recursion, because you are in the pre-order function and you are again calling the pre-order function. And that's why actually recursion, understand the recursion is very important, but unfortunately we are actually not getting the time to uh, spend on the recursion. But the basic idea is this one, that you are calling pre-order function from pre-order function itself. So when you call a function from itself, we call it recursion. Now let's go for the next one. So if you actually write your code in this way, okay, you can actually implement the pre-order traversal. And now comes for the in-order traversal. So what is the change between in-order and pre-order? In the in-order, okay, if I start with node A, again for the same purpose, so I will start with again node A. Then in the next line, in case of pre-order, what we did, we have written A, B, C. That means first the root, then the left child, and then the right child. In case of in order, we will start with B, A, C. That means first we have written the left child, that is B, the root, that is A, and the C, that is the right child. Then same goes for the next line as well. Okay, if we go for the next line, okay, what we have, okay, I can actually make it a better, it will look better, just to give me a minute. In this way to look a little bit better. Okay, now in the next line, okay, we will now expand B. Okay, so what is the left child of B? That is D, and then we will write B, and then we will go with E. So for this small subtree, B is the root, D is the left child, and E is the right child. And in the in order, we first write the left child, that is D, then we write the root, and then we write the right child. For the A, we will not do anything because we have already expanded A. For the C, we will again apply the same. Okay, the left child, that is F, the no root, that is C, and the right child, that is G. So we're done with this one as well. Now, can we expand anymore? Yes, D can be expanded to left child, root, right child. So for the D node, the small node of D, what we did, we have written the left child first, that is H, then we've written the node root, that is D, and then we've written the right child, that is I. Then we have, B, E, A. B is already done. E cannot be done because you don't have any child. Then A is already done. Then F cannot be done because F don't have any child. C is already done. G is already done. So this will be your final answer. H, D, I, B, A, C, G. So basically what we did, this is same as pre-order. Just instead of writing, what we did, we actually done it step by step. And if you want, you can do it in one step as well. Okay, no major changes. Now, if let me give you one more practice. So let's change this tree a little bit. Okay, so again, let's just add two more here. Let's name this, okay, let's name this M, and let's name this N. Now try to draw the in order traversal for this one. For this one, it starts with A, then it will go like this, that A, B, A, C. Why I did this? Because the left child should come first, then the root, then the right child. And then in the next case, if I expand B, D will go first and E will go in the right side, and A is already done. And C, if I expand C, it will look something like this, G. Then I'll again start with first one, D. Is D done? No. So the left child of D and the right child of D. Is B done? Yes, B is already done. Is E done? E, yes, it doesn't have any child, so it's done. A done? Yes. F done? No, F is not done. So M and N. Is C done? Yes. G done. Yes. So basically this was the answer and all of you have done it. So now for the last case, we have the post order. Now, without showing you the slide, I guess you can say that how the post order worked, right? Again, the code for in order is same. You see nothing different, same node, okay, same two left and right pointers, okay. Just now what you say that in case of in order, first we check if the root is null or not, that we did before as well. Then we actually call the in order left function, then we print the root data, then we call the right, okay. Previously what we did, we also written the same function, the line was just different. And you will see that just changing the order. You see here, we first printed, okay, if you look closely, we first printed the root data, we then use root left and root right. And in case of in order, what we're doing, we're just moving this line in between these two lines. That's it. In case of post order, what we'll do, we'll move this line to the last, okay. So basically this three line, okay, they just change the order and it actually make huge changes, especially if you're doing a applications or if you're implementing in this tree in any field, okay. We'll see, just all you have to do is do the simple changes and it will actually have a cascading, that means a lot of changes affecting on other changes. Anyway, so as you can guess, in the post order, the print root node will be at the last, okay. And then here, this is a tree. So then this is the answer for this. So same way, what we do is first start with left node, then we write the right node, and then we write the A. So if I actually show you how it works, basically, let me just type it down. So start with A, okay. Start with A. What is the left? Then what we do, first left child, right child, then A. Okay, so B, C, A. And then again for the B, left child, right child, and then B. C is already, for C, F, G, C, okay. And A is already done. Then again, it will go on. For the D, it will be H, I, D. E is already done. B is already done. F is already done. C done. And after C, we have A. Okay, I missed one. That is G. Where is G? Okay, G is here after F. My bad. So anyway, the meeting will restart now. Join again.